such a small map.
The whole bag is the size of it.
Hey, yo, that is a big stick. Not a big stick, that's a small stick.
You got the.
That's about average, that's it. Hey, that is humongous. What do you mean? Massive.
All right, take your notes out, please, from last week.
But can we just combine last week's assignment with today's? Button.
Three dots was.
Hey.
Okay.
That's me. That's me.
All right, does everybody have their notes out?
That's me.
So we're gonna go and do the last page of the notes first, and then we're gonna go backwards. Hopefully you guys got my message over the weekend.
That was because of me, guys. I was the student.
Thank you,
No.
Owen.
Yeah.
Miss Bond, I got the message and I stopped right there, just to be sure that I didn't.
I only did the first three problems, so.
Yeah.
Okay, so everybody go to the last example in the packet. We don't need yours. Out. This class is crazy enough. All right, so this is the last part of, or the last thing, and I thought you guys would get what we were doing enough to do these problems, but that's my fault. So, okay, so what happens is this, you have to really understand the unit circle, okay?
I see that
So-
first one is in the bottom right.
I understand it.
Yep, so cosine of 240 is right here, okay? Which is this point, right? And this coincides with this point. Now, do you guys get that this is the tangent, obviously? And the first thing in the ordered pair is your cosine. The second thing is the sine. So isn't this the cosine of 240? Do you get that? And this is the sine. See ya.
Good luck, guys.
So
Yeah, good
this
luck, Matthew.
would be negative 1/2. Do you understand that?
Yep.
Okay. Now it says to do tangent of 3 pi over 4. So what you're gonna do is look at these blues until you find 3 pi over 4, which is right here. And this one's tangent, which is right here. Do you get that?
Where's 3 pi over 4?
3 pi over 4 is here,
It's so hard to read.
which goes with these. You know what? There's a better unit circle on your cheat sheets. So if you take out your cheat sheet, this would be better, like Mason has here. Take this out.
The big one.
Yes, this will be a lot easier to read. All right? So do you guys get that the tangent of 3 pi over 4 would be negative 1?
Yes.
Okay. Then it says sine of 315. So do you guys get right here is 315? Here's the point. Well, actually, no, that can be a little bit deceiving. This point goes with 360, this point goes with 330, this point is 315,
Yeah, that makes sense.
okay? So the sine of 315, is it the first or the second thing in? It's the second thing, so wouldn't it be this right here?
Yes.
Negative root 2 over 2, okay? Now they're asking us for cotangent of 3 pi over 2. So 3 pi over 2 is 270 right down here. Okay, cotangent of this. And this goes with that as well as this does. Okay, do you guys know which trig function cotangent is the reciprocal of?
Tangent.
Yep, and the tangent of 3 pi over 2 according to our unit circle is undefined. Do you guys remember what we said on Friday?
Zero.
Yes,
Zero.
so this would be 0. Okay? Then they want the cosecant of 5 pi over 6. Do you remember which trig function? Sine. Cosecant is the reciprocal of sine. The sine of 5 pi over 6, so you find 5 pi over 6, which is right here. Which one of these is sine? 1/2, right? So the sine is 1/2. The cosecant is going to be the reciprocal of a half, which is 2. All right. Then secant of 120. Here's 120. Here's the point. So here's what the information is. Now, which one is yeah, Nolan?
So we're having a different assignment then?
Yes. Not a whole lot more, but you are, yes. So
Like shorter than
secant
Friday?
of 120, what is the secant the reciprocal of? Cosine, yes. What is the cosine of 120? Isn't it this one?
Yes.
Negative 1/2. What is the reciprocal of negative 1/2? Negative 2. Okay. All right. Now, when they say cotangent, Mason, turn around. Cotangent of negative pi, do you guys get that that's going to be going in the clockwise direction? Negative pi is going to be going around. You also could do this. This probably makes more sense, is to find a coterminal angle with negative pi, and negative pi plus 2 pi would be what?
Pi.
Pi. So either you can know that negative pi is half of the circle going this way, so this is also negative pi, or you could add 2 pi to it to find out that it's pi. Now, tangent, yeah.
Sorry about
No, that's
that. Is
okay.
coterminal the thing where you like add 360?
Yep, and if it's in radians, you'd add 2 pi or subtract 2 pi. Yep, good. Now, tangent of negative pi, or pi is 0, what is the reciprocal of 0?
Undefined.
Yes, so this is going to be undefined. Okay, then it says to find the secant of 9 pi over 4. Now, 9 pi over 4, if you look at this graph and you go around, it's not on here, okay? When 9 pi over 4, if you think about that, 9 divided by 4 is 2 1/4. So that means it's more than one time around the circle, okay? So what that tells you then is you have to find a coterminal angle with, what is it again, 9 pi over 4. And how you do that is you either add 2 pi to it if it's in radians, or subtract 2 pi from it. So do you guys get that I would do 9 pi over 4 minus 2 pi to get it so that it's on the unit circle? And what I would have to do if I'm doing this is I'd want to get both of those over the same denominator. So if I have this over 4, I have to multiply this times 4. Okay? So I would have 9 pi over 4 minus, this would be 8 pi over 4. What's 9 pi over 4 minus 8 pi over 4?
Over 4.
Pi over 4. Now, is pi over 4 on the unit circle? Isn't it right here? And they're asking for secant. What is secant the reciprocal of? Which is
Cosine,
another
no.
thing.
Yeah, cosine.
Yep, secant is the reciprocal, and that, you guys, is on your cheat sheet too, right here. Okay, so it is the reciprocal of So if you went cosine of pi over 4 on your unit circle, you would get, which one is the cosine?
Square root of 2 over 2.
Yep, square root of 2 over 2. Okay, that is our cosine. We want the secant at pi over 4. So wouldn't that be the reciprocal of this? Which is 2 over root 2.
Well, then you have to change it, right?
But I'd have to change that because I can't keep a radical on the bottom. So I multiply by root 2. And I get on top 2 root 2. What's root 2 times root 2? 2. Can I ever reduce something under the radical? I can't. But could I reduce these 2's? Yes. So what would our answer be?
Square root of 2.
Square root of 2. Yep. All right. The next one asks us to first find an angle that's between 0 and 2 pi. And because it's negative, you would have to add 2 pi. So we're going to take negative 11 pi over 4, and we're going to add 2 pi. Now, to do that, we're going to put this over 4, which means we're going to multiply this by 4, okay? And what we would get there is negative 11 pi over 4 plus 8 pi over 4. What would I get when I do that? What would negative 11 pi over 4 plus 8 pi over 4 equal? Negative 3 pi over 4. Do you think I can do that? If it's
Probably.
negative, what would I have to do? I'd have to again add 2 pi. So what that means is I was over one, I have to add a whole circle around twice to get that angle to be a whole number or a positive number. So I'm going to add 2 pi again, which isn't adding 2 pi, really adding 8 pi over 4, right? So I'm going to write 2 pi as 8 pi over 4. What would we get when we do negative 3 pi over 4 plus 8 pi over 4? 5 pi over 4. That is going to be something that's on our unit circle. And if we look here, 5 pi over 4 is right here. This is my point, so this is my information, okay, that I underlined there. So we want cosecant. Which trig, yep, Laura?
Why don't you compute so that you get how it's 9 pi over 4 for the last one? Couldn't you just go to the pi over 4 and count like that part and leave it and then
Say that again. It was 9 pi over 4, so you're going to here.
yeah, and then
So this is 1, 2,
yeah.
is that what you mean?
Well, it's like after it, so we would put the
So you're saying going here,
yeah.
and then what?
And then walk to-
Yeah, for sure.
So say it's 9 pi over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Do you guys get that?
Yep.
Because isn't this like an eighth of the circle? Do you get like this is a half of the circle? Or no, this is a quarter, right? This is a
Yeah,
quarter,
yeah.
this is a half. So this is an eighth. So she's saying if there's 9 pi over 4s, right? Here's 1 pi over 4. So then this would be another pi over 4. So that's like 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them, 8 of them, and then 9 of them should be back there.
Mhm.
So you could do that.
I think it's
Okay.
easy. I think it's easier the other way. But
If you don't go like all the way around, you just know you have to minus 8 right away from that.
If you, for something that's a 4, yes.
Yeah.
Because 2 pi is 8 pi over 4, so you'd be subtracting 8, yes. Yep. Okay, So we are going to end up right here, correct? And we are doing cosecant. What is cosecant the reciprocal of? Cosecant
Sine.
is sine. So we're going to first find the sine of pi over 4. And the sine of pi over 4, if you look here, which one is the sine in this?
Where would 2 over 2?
Yep, this one. So that is square root of 2 over 2. So if that's the case, your cosecant of pi over 4 is going to be the reciprocal of this, which is 2 over root 2. Can we leave that?
No.
So I'd multiply by root 2, right?
Mhm.
And I'd get 2 root 2 over what?
2.
2. And what happens to your 2's here?
Yeah, cancel.
And our answer is root 2.
Mhm.
Do you understand that?
Yep.
I'm wondering,
Yeah.
you get something with like the root 2 on the bottom and it's the same denominator, like the same number up top. Can we just automatically know to take out the 2 and just keep the bottom number? Like not covered?
So you're saying like if you get this and you flip it, if these two numbers, like if you have 2 over root 2,
Yeah, if it's like.
and
the same
these two
on the
numbers
bottom,
are the same,
And
will
you
it
know-
always be root
It'll
2?
always just be the bottom number. And so can you just not do that part and then just cut, take out the.
I think, like you're saying, like if it's 6 over root 6,
Yeah,
would it always be root 6?
yeah.
Yes.
Okay. So then would we have to show work for the math after?
No, if you get that, that's okay.
Alright.
All right, are we okay on that type of problem now?
Yep.
Is
Every-
the last one not negative?
Is the last one not
Or given
negative?
It's supposed to be negative.
It's gotta
No,
be between 0 and 2.
because it's here in the first quadrant, it would be positive. Yeah. All right, everybody okay with that?
Yeah.
The other thing I should say too, do you guys get that in the first quadrant, all of your sine, cosine, and tangent are positive?
Mhm.
And then do you remember all students, so what a student starts with S, so which one's positive here?
Sine.
Sine and the reciprocal of it, which is
Cosine.
Cosecant.
Cosecant.
those are the positives. Then it's take, and isn't tangent the one that starts with T?
Yes.
So the ones that are positive here are tangent and its reciprocal, which is cotangent. And then it's calc or chemistry, whatever you want to put here. And that would be cosine is positive and secant is positive. Do you get that?
Yep.
Okay. All right, now, the last thing we need to talk about today is reference angles, okay? Now, just to show you guys where the general reference angles go on a graph, okay, and this might be something you want to put on your cheat sheet somewhere, but when they're talking reference angles, these are the angles they are talking about, okay? Some kids have troubles knowing how do you draw the reference angle in each quadrant. So in quadrant 1, this would be your reference angle. In quadrant 2, this would be your reference angle. And then quadrant 3 is this one, quadrant 4 is this one, okay? All right, so again, if you're doing it in quadrant 1, it's going to be this. In quadrant 2, it's this. In quadrant 3, it's this. And in quadrant 4, it's this, okay? Yeah,
What is a reference angle?
I will explain that. So there are times when you're doing problems, okay, where they will say, draw a reference angle for a 135-degree angle, okay? So this is 0, this is 90, this is 180, this is 270. This is back at 360. So 135 is between 90 and 80, okay? So do you guys get that 135 is going to be in this second quadrant? This is 135. That's this angle. A reference angle is an angle that is between 0 and 90 that makes, it's this angle right here. And what you do is you take the tip of the arrow on your angle, you draw it down perpendicular, and this would be your reference angle. And instead of it being 135 degrees, we'll look at what you do, but in this case, what's in the second quadrant, you take 180 and subtract whatever angle theta is, okay? What's 180 minus 35? That's 45, so that would be our reference angle, okay?
That's not too hard.
If you're down here, okay, what the rule is you take your angle and you subtract 180. So say this big angle in here was, say, 225, okay? 225 is between 180 and 270. So how you would find that is using this formula. You'd go 225 minus 180, and it's 45, correct? And they're not always going to be 45. That's just the way I did that. And then let's say that you are given one in quadrant 4 that's 330 degrees, okay? So you would have a reference angle here, okay, that's 330. What the formula is here is you would take 360 minus your angle. So this is the formula for quadrant 2. This is the formula for quadrant 3, and you'll see that on the next page. And then this one is 360 minus your angle. So what would your reference angle be here then? What's 360 minus 30? 30. Okay. And the reason is it's an easier angle to work with. And when you guys get into trig, you use 30, 60, 90, and 45, 45, 90 triangles all the time. So that's what you're trying to set up. So if we go here, okay, this should be on your cheat sheet. It is, okay? This right here has the formulas for the first quadrant, second quadrant, third, and fourth, and it has it both in radians and in degrees. Okay, I'll get you one when I'm done, okay? So if you're in the first quadrant, your angle and your reference angle are the same. So if your angle's 45 degrees, your reference angle is 45 degrees. They're the same. If you're in quadrant 2, the top formula is what you would use if you're in degrees. The bottom formula is what you would use if you're in radians. If you're in quadrant 3, you use this one if you're in degrees, this one in radians. Quadrant 4, this in degrees, this in radians. Okay, so the first example here, we're going to be using the top rows formulas because we're in degrees. The second example we're going to do is going to be using radians. So this is what it's saying. If you have a 210 degree angle, what would your reference angle be? Now remember, this is 0, this is 90, this is 180, this is 270, and this is 360. What quadrant would 210 be in? Quadrant 3. Do you get that? Okay. All right. And that's how you always draw your reference angle. You go to the tip of your angle, because 210 really is this angle, okay? You go to the tip, and you either draw perpendicular up to the axis, or if you're up here, you would draw perpendicular down to the axis, and you form this right triangle. Now, to find what your reference angle is, I'm going to just erase this. What you would do in quadrant 3, here's quadrant 3, is you'd use this formula. Here where it says theta with a prime, that's your reference angle. And to find that, you take your original angle and subtract 180. So all you would do here is you would take your original angle and subtract 180, which is 30. That means this angle is 30 degrees, and that is your answer. So when you're doing these, you have to sketch it, and you have to write what it is. Is that easy enough?
Mm-hmm.
Okay. So now if you have one that's 285, okay, remember this is 0, 90, 180, 270, 360. Where would 285 be?
In the middle of 360, 270, a little bit more towards 270.
Yes. So say it's something like this. Now from the tip of this arrow, where do I draw? Up, perpendicular to the x-axis, right?
Mm-hmm.
Nolan? No, I'm doing that, but no, you do not have to. Now, if it's in the 4th quadrant, you go to this chart, which you have on your cheat sheet, and you use this top rule because you're in degrees. So do you get where you would just take 360 and subtract 285? And 360 minus 285 is 75 degrees. And then would you guys know that that 75 goes right here? Everybody okay with that? Okay. Now, of course, they're going to start giving you some that maybe aren't on the unit circle, and that's where you have to find a coterminal angle that is on the unit circle. So if they gave you negative 250, how would you get something that's on the unit circle?
Add 360.
Add 360. What's negative 250 plus 360? 110, right? Is it 110?
Yeah.
Okay, so think about your unit circle. Where would 110 end up? Quadrant what? 2nd quadrant, right? Everybody understand that? So 110 would end up just past 90. So say it's like this. Here's the tip of my angle. Do you get that I draw down perpendicular to the x-axis? All right. Now, I'm in quadrant 2, and in quadrant 2, I use this rule. I take 180 minus my angle. So what would I get? If I did 180 minus 110, what is that? 70. So that's my reference angle, and this is 70 degrees.
Oh, did you figure out the problem? I did. Okay, and I went on the oh, that's beautiful.
There you go. Okay. Yes, they were just in this class.
I figured.
So we figured it out. Okay, thank you. All right, are we good then? Everybody understand that? Okay. Now radians is a touch harder. It's the same idea. It's just that you're adding and subtracting 2 pi, so it's a little bit harder, but not too bad.
What do you do for the
Okay.
first one?
Now, I'm going to show you a trick that I use, and hopefully you understand this. So if you're deciding what quadrant is 4 pi over 3 in, okay, here's what I do. Do you see here, 0 degrees is 0. If you're trying to figure out what 2 pi is, you can go 2 times 3.14 to get that as an actual number. And 2 times 3.14 is 6.28, okay? For pi over 2, to get that as an actual number, you can go 3.14 divided by 2, and that's 1.57, okay? Then over here, pi is 3.14, correct? And down here, if you just went on your calculator and went 3 times 3.14 divided by 2, it's 4.71. These numbers right here are important because when you're doing these and you're trying to figure out what quadrant is this going to be in fact, on your cheat sheet, do I have that at all in there? Okay, go to this graph on your sheet. Do you guys have your cheat sheets out?
No.
Take it out, and I'm going to have you add those numbers to it. Does anyone need the formula sheet besides Owen? Okay, so go to that all students take calc graph. Okay, and what I want you to do is over here on the positive x-axis, put 0 or 6.28. Up here at the top, put 1.57. On the negative x-axis, put 3.14. On the negative y-axis, put 4.71. Okay, and you'll see why we're doing that. To be able to know what quadrant that angle is in, you're going to go to your calculator and you're going to type in 4 times 3.14 divided by 3. Does somebody want to do that? What is 4 times 3.14 divided by 3? 4.186. Okay. 4.186, do you guys agree, is between these two? Nolan said it's 4.186. Isn't that between 3.14 and
Yes.
4.71?
Yes.
So what that tells us then is our reference angle is going to look like this in quadrant 3. So why I have these numbers is so I can decide where that goes. Yes?
You just do 3.14 and then like 4 times 3.14. Right?
You can, because it's just an approximation. You can, but not all the time will they be on the unit circle. Okay, this is what Mason, and the reason I don't teach it this way. If you look on the graph, there is a 4 pi over 3 on here. And you could look for it and see if it is. If it is, then you know where it is. But there could be some times that it's not on there, and then this is how you do it, okay? So you can certainly check. If you get an angle, look if it's on your unit circle, and that would tell you which quadrant it's in. But I showed you that way so that you would know what to do if it's not on the unit circle, okay? So now, we are in the 3rd quadrant, and we are doing radians. So you'd use this, go to quadrant 3, and use this formula. Theta is your angle minus pi. So we would go 4 pi over 3 minus pi. To do that, you have to put it over the same denominator. So you would get 3 pi over 3. Do you understand that?
Mm-hmm.
Okay. And what would 4 pi over 3 minus 3 pi over 3 be? Just pi over 3, correct? So that is this angle right here. And that would be your reference angle. Okay. Then if we go down here, let's use Mason's way. Is 11 pi over 6 on your unit circle?
Yep.
In quadrant
4.
4, okay? So you can certainly check that. If it was not, you would take a calculator and go 11 times 3.14 divided by 6, get it as a decimal, and it would be something between 4.71 and 6.28, okay? Now, 11 pi over 6 is in quadrant 4. So if we go to quadrant 4 and use the radians formula, it's 2 pi minus our angle. So it's going to be 2 pi minus 11 pi over 6. Would you guys know to do this, you have to get this over 6, which means you have to multiply the top by 6. So this would actually be 12 pi over 6 minus 11 pi over 6, which would be what? Pi over 6. So this is pi over 6, and then right here is pi over 6. So you'd have this drawing as well as your reference angle. You guys get that? Yes, you'd put it right here, and you'd list it as a reference angle. Okay? Well, when you do your homework, you can. Okay? All right. What's that? Like
Yeah.
to it? Yes, you could do that. All right, so if you guys look at this, do we have to do something to this?
Yeah.
You have to make a positive, right? How do you do that?
And
Add 2 pi. When you add 2 pi and you have to put it over 4, do you get that you'd multiply this by 4? So you'd have negative 7 pi over 4 plus 8 pi over 4, which is what?
pi over 4.
Pi over 4. Okay? That is our angle then that we are trying to find. If you look at your unit circle, what is pi over 4? Is that on your unit circle? In quadrant 1, right? So if I did this, okay, that would be my reference angle. It's at pi over 4. Now, if you look at the rule in radians for quadrant 1, whatever your angle is what your reference angle is. If it's in the first quadrant, whatever your angle is what your reference angle is. So this would be pi over 4, and right here would be pi over 4. Is that okay? Okay. Now we have one more, okay? Do I have to change this to positive first? Okay. How do I do that again?
Add 2 pi.
Add 2 pi, okay? And wouldn't I have to have it over 4? So that means this is multiplied by 4. So I would get negative 3 pi over 4 plus 8 pi over 4. What would I get then? Mason said it. Isn't it 5 pi over 4? Now is 5 pi over 4 on your unit circle? In what quadrant?
3.
3. So that means your reference angle is going to look like this, okay? You're in the 3rd quadrant, and for radians in quadrant 3, we take our angle that we have and we subtract pi, okay? So we would take the 5 pi over 4 and we'd subtract pi. Do you get to do that? You would put this over 4 and you'd have your 4 there. What's 5 pi over 4 minus 4 pi over 4? Pi over 4. Okay, so that's your reference angle, and that's what would go right here. Everybody okay with that?
Yep.
So most of your homework today is going to be doing this, okay? And then I put on here that now you're good. Now you can go back and finish those from Friday. But this is what's new today, just these.
Oh my gosh.
Oh my gosh.
That's like 2 assignments in one.
It's actually like 3.
These, you guys, these right here are just looking at the unit circle, like that first example. So they're quick, yes. Yeah, why don't we, do you want to do that? Do you want to do it all together? Okay,
Yeah.
all together?
You got it?
Not back to the bathroom.
You can.
What button?
Owen,
I've given
you
it.
got it?
Button, may I please go to the bathroom?
Yeah.
Oh, thank you.
So I just attached my assignment to this one. The one from Friday.
Yeah.
Yes. This is the one that was due today.
Mhm.
Yeah, so did you understand what I did on Friday? You could do these?
Mhm.
Okay,
Oh, yeah. I already
But-
did them.
yeah, but I guess we're just,
Yeah.
do you guys want to put it as all as one?
Yeah.
Okay, so just wait till you finish today's and then
And
staple
then
it
staple
together.
it? Oh, yeah.
Yeah,
No.
When you're waiting for us to do this,
They should be doing 3 days.